Skill number 2 is write decimals in order. Please be sure that you have looked at computation 141 that goes along with this lesson. And let's start in the left margin at our notes. Comparing whole numbers. The number with the greatest number of digits is the greatest. 123 is greater than 12. So what they're saying here is that 123, that has 3 digits. This one has 2 digits. So since they're whole numbers, I can tell you that 123 is greater. So I would write that as 123 is greater than 12. Comparing decimals, the number with the greatest number of digits may not be the greatest number. For example, 1.23 is not greater than 1.3. So this one would be 1.23 is less than 1.3. And we're going to learn in this lesson how to do this. Okay. Comparing decimals, another approach. Write each decimal to the same number of decimal places. Add zeros as needed. And that's what they've done here. I suspect this is going to be one of my examples that we'll look at. So you would line them all up on the decimal point, and then add zeros wherever you need to even out the places. And that will help you compare the decimals. I'm thinking in the next video, I may not start in the left margin. We may start with the reading and then refer to those. I think I'm doing it backwards. But for this one, I think we'll be okay to look at the first example. National Pipe Company stocks copper pipes in the lengths shown in the table. What is the part number of the longest pipe? So we are looking for the length of these pipes. That's this column. This column is giving me the part number. And they want to know the longest pipe. So that is another way of saying the greatest. What is the greatest decimal in this list? So how did they arrive at number 2? They're saying that the correct answer is right here. That this is the longest pipe in meters in the table. So let's see how they arrived at that answer. Step 1, we need to compare the lengths in the length column to find the longest length. Compare each length digit by digit, starting with the greatest place value. So what they're saying here, they start with the greatest place value. That would be the thing furthest to the left. So that column is the greatest. All right, we know that of this red box that I've highlighted here, the 7s are the greater numbers. So we know this is not the answer. Remember, we're looking for the biggest one. We know that that's not it. It has to be one of these with a 7. So then we would go to the 10th place, the first decimal place, to look at the next set. And let me do it right here, just so you can, your eyes won't cross on you. Okay, of those, we're looking for the largest one. So it's not this one. The 3 is the biggest one. It's not this one. It is this one. That is the largest of those numbers. So the greatest digit is 7.3, and that's where they got part 182C. Okay, I will tell you that this method, although I get it, this is not my preferred method. I'm going to show you how I would do it, and then you can decide which you prefer. Step 2, I need to go ahead and finish. The part that goes with 7.3 is 182C. All right, here's how I would do this. And I'm going to do it right up here, I believe. Okay, I'm going to write my decimals carefully from the table. So I have 6.09. Graph paper is wonderful for this, but it's okay. 6.78, 7.09, 6.7, 7.3, which we know will be the answer, but 2.8, 7.076, 5.99, and I want to be sure that my decimals are lined up, and they are. Then I would go back and add zeros to line everything up. So let's look at the longest number, not the largest number, but the longest one, the one with the most digits. It has 4 digits. So I'm going to use zeros to give everybody 4 digits. So there's 1. This one needs 2 zeros, as does this one. This one just needs 1, and this one just needs 1. So it always helped me to see this in an even distribution. Okay, I will look at my first column. That never changes. You want to start with the leftmost numbers. And of those, I know that my 7s are going to be the largest. So I'm going to, I think, cross off. That seems to be the best way. I'm going to get rid of this one, this one, this one. I'm doing the same thing we did before. I've just put in those zeros as placeholders. So here I have 7.090 or 7. You're looking at 90, 300, 280, and 76. And of those, which is the largest? And it is, of course, the one it was the first time. It's going to be this one. Oops, that's a little too big. So we are comparing decimals or putting them in order from largest to smallest or smallest to largest. You can go either way. All right, on page, which page am I on? Page 17. Let me get my book turned around here. Again, we have concept, procedure, and application, and those get gradually more difficult. So let's take a look at the concept. According to the bar graph, which is the best estimate of the cost of 1 gallon of milk in Dallas. So the title of the graph is Cost of 1 gallon of 2% milk in selected cities. In Boise, Idaho, it looks like it's just a hair over $2. In Dallas, it's between $2 and $2.50. So that's about $2.25. This one might be $2.20. I'm sorry, $2.02 maybe. And then in Seattle, Washington, we're at halfway between $3 and $3.50. So that would be $3.25. And they're asking about Dallas. So I'm looking at this one. You can tell how old this book is, if that is the average cost for a gallon of milk. But the answer there is number... Whoa, I missed that. I'm not going to record this video again because I made a mistake there. Did you see what I did? $2.50 would be way too high for this one. So let me erase that. I will do that much. Well, I said I would. That's how easy it is to mark the wrong answer. My estimate is $2.25, which is closest to that answer. It's going to be number 3. And hopefully you did not do what I did. Hopefully you got that one right off the bat. Sorry about that. I'm very sleepy. All right, number 2. We're still in concept. Problems 2 to 4 refer to the table on page 16. So let me go back to this table, and I am going to erase that part, and I think I'm just going to take a picture of the table so I don't have to keep flipping back and forth. I will tell you that I tend to make my mistakes with concepts. The harder the problem is supposed to be, for me, the easier it is, because it is giving me a story. It's giving me a context. So these that are just asking about the concept give me trouble. I need to very much pay attention here. All right. Which is the part number of the shortest pipe that is longer than 6 meters? The shortest pipe that is longer than 6 meters. So let me show you how I would do this one. Let me do this. I'm just looking for some space to write, and then I will delete this. So let me go ahead and put it right here. I'm just going to do what I did in that first example, only this time I'm going to draw a line for my decimal place so that it's a little more organized. All right, the first pipe is 6.09. Then 6.78, 7.09, 6.7, 7.3, 7.28, 7.076, 5.99, and then I'm going to come back in here and line everything up with zeros. And I'm doing this entirely for me because I know how my brain works and I need to see it lined up. Now I'm going to take a picture of this so I don't have to do it again. If you need to pause the video, that is fine. But I'm going to just bring this picture right up here. All right. Okay. The shortest pipe that is longer than 6 meters. So if it's 6 meters or more, we're going to count it. So we would eliminate number 5. Excuse me, not number 5. The bottom one, 5.990. That is shorter than 6 meters. All right? Longer than 6 meters. That would be any of these here at the top. Even that first one is just a hair longer than 6 meters. So the question is, which of these is the shortest one of these? Which is the smallest one of these? Well, we can eliminate our 7s because they're bigger than the 6s. So get rid of your 7s and then ask yourself, of the 6s, would it be 90, 780, or 700? Which is the smallest? And that is going to be this one. Now, I need to figure out which part corresponds to that one. And that's where I'm going to need this picture to come up here. It probably would have been easier to just flip back and forth. So that first one corresponds to 123C. And let me bring this down here so that I can mark this 123C is my answer. Okay. How many of the pipes listed, I want this one. How many of the pipes listed are longer than 6.5 meters? So let's come in here. We want anything longer than 6.5. So we can eliminate the 5 right off the bat. All of the 7s would stay in the game, but we're looking for things bigger than 6.5. So 6.09 would not be. If you compare that to 6.500, that one would not be longer than 6.5. The others would be 678 and 670. Those are bigger. So, how many of them are there? There's 1, 2, 3, 4, 5, 6 of them. So I would go with option 2. 6 of them are bigger than 6.5. How many of the pipes listed in the table are between 6 and 6.5 meters long? Okay, so we can eliminate the 5. It's too small. We can eliminate the 7s because they're too large. Okay. Now, you can look at these and probably find your answer, but I want to show you a little trick. If this messes with your mind like it does mine, this is a way to look at it. So take the 6, and again, I'm going to line up my decimal points carefully, and then 6.5 comes down here. And I'm going to give everybody 3 decimal places. Okay, so those are sort of our benchmark numbers. Those are the top and bottom of the range we're looking for, the minimum and the maximum. All right, so here we have to look at 090. It's definitely bigger than 6, but is it smaller than 500? It is. The 90 is smaller than 500, so we could put that one in here. Then I look at 780. Is that smaller than 500? No. Then I look at 700. Is that smaller than 500? No. So the only one of those that would fall in that range is that first one. And so the answer to this question is 1, which is option 2. I hate that. I wish that were a B and not a 2. To me, that would have been a very tough question. Those concept questions I hate. I am not much more fond of the procedure ones, but a little bit more. At least there's a story that I can get a hold of, but I don't like any of these. I'll just be honest with you. I have dyslexia, and this type of skill really drives me crazy. Janet has packages to mail with the following weights. Which of the following lists shows the weights from least to greatest? Now, I have friends who can look at those numbers and just tell you. I have friends who will look at those numbers and start trying to figure them out, and that is okay. But this is my way of doing the problem. You can choose what you like. I make my line for my decimals, and I start laying these in here. 0.6, 0.07, 0.8. It looks like there are only 4 packages. I went a little wild on my line here. So, okay, so this is putting them in, not in order, but it's lining them up on the decimal. And I can tell you that everybody needs 2 decimal places. And once that went in there, I can see easily it wants least to greatest. Now that's something you want to be careful of. Make sure you know the order that it's asking you to use. So least means smallest. And of those, you can think of money here. Which of those is the smallest amount of money? Well, it's that 7 cents. So 0.07. And then the 6. And remember, I added the red 0, so I'm just going to leave that off. Then 76. And then the 8, I added the red 0, so I'm going to leave that off. And this is the answer. This is the sequence we're looking for. We just have to match it to one of our choices. So 0.07, 0.6, 0.76, and 0.8. So I like answer 4 on this one. Let me just double check that because I know myself and I'm not good at these. I will look at something and think I have it and then I don't. But that looks pretty accurate. Least to greatest. If you don't need to do this, don't do it. It's okay. I'm just showing you my thinking strategy. The times for the final heat of the girls' 100-meter run at Albany High School were: which was the fastest time? Be careful. All right, here we go. Again, you don't have to do this if you don't want to. This is just my way of doing it. So I have 12.5, 11.8, 11.98, 12.02, and 11.79. And it looks like everybody needs 2 decimal places. Okay, be careful. If you are running a race, what does fastest mean? Now think about that. If you're running the race, what does it mean to be fastest? It means the least. If you're running a race, the least time is the winning time. So we want to know the smallest amount of time in this list, not the largest. And that used to get me all the time. You have to think about what the story is saying. So if I want the smallest, it's not going to be the 12. It's not going to be that 12. It's going to be one of these 11s. So 1180, 1198, or 1179. This is the smallest one. This person ran the least amount of time and covered the same amount of space, 100 meters to be exact. So 11.79 is the smallest of the three 11s. All right, application. I like these. Kendra has several lengths of rope. She will cut one to be exactly 6.4 meters long. Which length of rope should Kendra cut if she wants the least waste? All right, let's take our numbers. Now be careful. You don't want to jump to the conclusion that it's the smallest number. I would encourage you to go ahead and build this little picture so it will help you think it through. .01, and it looks like everybody needs 2 decimal places, so I'm going to add those in there. All right, we know that she needs 6.4 meters. So I'm going to take that number and I'm going to give it 2 decimal places because I want to see everybody on equal terms. So she needs 6.40 meters of rope. So look at that 6.05. 6.05 is not big enough. This one is too small. So you can eliminate that one right off the bat. It is too small. It's less than 6.40. It's 6.05. So that is not your answer. Now, here's the next thing. These pieces that are remaining are all big enough. Which one would be the least amount of waste? If I use the 9.3, that's going to give me almost 3 meters of rope that would just get thrown away. So of the ones that are left, this one is the closest. You're still going to have some waste, but you wouldn't have as much as if you used the 9 or the 8 or even the 7.6. So of those remaining, this one is the closest option. I love that question. But I will tell you, I've seen lots of students miss that because they went for that 6.05. But you have to realize that is not enough to make what she needs. Again, if you have not done the computation review, I would recommend that you do those. Those are good exercises. on those pages in the back of your book. One other thing, you notice there are no calculators here. So if these were actual GED questions, you would not have the calculator. All of this is mental math, and it is not easy. I hate this lesson, but it doesn't matter that I hate it. It is still part of the test.